conducted on patients with asthma to compare a new treatment of asthma with a placebo one. After 12 weeks of the therapy, the mean symptom scores were 2.8 plus minus 0.1 in the treated group as compared to 3.1 plus minus 0.1 in the placebo group. And the p-value is 0.035. The investigator of the study stated that they choose a sample size of 100 subjects in each group to have an 80% power of detecting a mean difference of 0.4 at a significance level of 5%. When planning a study, which of the following of 80% of the power? So the answer is if the treatment really changes the mean asthma score by 0.4, there is an 80% chance that a study of the size will have a p-value less than or equal to 0.05. So the explanation of this question is, let's break this question down carefully because it's really about study design, power, and p-values. So the key concept is asthma study comparing new treatment versus placebo. Outcome is the mean symptom scores after 12 weeks. So the treated is equal to 2.8 plus minus 0.1 and placebo is 3.1 and plus minus 0.1. So the p-value is equal to 0.035. Study planning. They choose 100 subjects per group. Goal is 80% power to detect a mean difference of 0.4 at alpha value is 0.05. So the question is, what does 80% power means in this context? Understand the p-value. The p-value 0.035 tells us if there were actually no true difference between the two groups, null hypothesis true. There is a 3.5% chance of observing a difference as extreme as 0.3 or more. Because the 0.03 value is less than 0.05, the result is statistically significant. Understand the study power. Power is the probability that a study will correctly reject the null hypothesis when a true effect exists. Formula is 80% power means if the true mean difference is 0.4, then there is an 80% chance that the study will detect it as a statistically significant p-value less than or equal to 0.05. Important discussion. Power is about the design, study design before study is done. It doesn't describe what actually happened in this study. So the p-value is equal to 0.035 is after the study. Link the numbers to meaning. Choose sample size of 100 per group. Designed to have each subject enough subjects to detect a mean difference of 0.04 with the probability of 80%. Observed difference is 0.3 less than 0.4. Still significant p-value is equal to 0.035, but in planning they assumed it as 0.4 difference. So the 80% power statement is if the true difference in the symptom score is 0.4, then in 80% of the sample studies of 100 patients per group, we would observe p-value less than or equal to 0.05. So this is the correct answer says. Common confusions. Power is not the p-value. A significant p-value doesn't mean you had high power. Power is pre-study probability of detecting a real effect. Power depends on expected effect size. Here 0.4 is mentioned. Sample size here is 100 per group, and significance level is shown by alpha is equal to 0.05. Standard deviation of measurements is 0.1 plus minus. So quick analogy is, imagine flipping a slight biased coin. You design an experiment to detect the bias 80% of the power. If the coin really is biased, I have an 80% chance of detecting that bias in my experiment. So the key concept is power is equal to probability of correct detecting a true effect. In this study, 80% of power means if the true asthma score difference is 0.4, this study has an 80% chance of showing a p-value less than or equal to 0.05. So ChatGPT helped me out to solve an NBME question of 21. Hope this helps and clears some concepts.